Streaming media is multimedia that is delivered and consumed in a continuous manner from a source, with little or no intermediate storage in network elements. Streaming refers to the delivery method of content, rather than the content itself. Distinguishing delivery method from the media applies specifically to telecommunications networks, as most of the traditional media delivery systems are either inherently streaming or inherently non-streaming. There are challenges with streaming content on the Internet. For example, users whose Internet connection lacks sufficient bandwidth may experience stops, lags, or poor buffering of the content, and users lacking compatible hardware or software systems may be unable to stream certain content. With the use of buffering of the content for just a few seconds in advance of playback, the quality can be much improved. Live streaming is the real-time delivery of content during production, much as live television broadcasts content via television channels. Live streaming requires a form of source media, an encoder to digitize the content, a media publisher, and a content delivery network to distribute and deliver the content. Streaming is an alternative to file downloading, a process in which the end user obtains the entire file for the content before watching or listening to it. Through streaming, an end user can use their media player to start playing digital video or digital audio content before the entire file has been transmitted. The term streaming media can apply to media other than video and audio, such as live closed captioning, ticker tape, and real-time text, which are all considered streaming text. Streaming is most prevalent in video on demand and streaming television services. Other services stream music or video games. Etymology. The term streaming was first used for tape drives manufactured by Data Electronics Incorporated that were meant to slowly ramp up and run for the entire track. Slower ramp times lowered drive costs. Streaming was applied in the early 1990s as a better description for video on demand and later live video on IP networks. It was first done by Starlight Networks for video streaming and Real Networks for audio streaming. Such video had previously been referred to by the misnomer store and forward video. Precursors. Beginning in 1881, Theatrophone enabled subscribers to listen to opera and theater performances over telephone lines. This operated until 1932. The concept of media streaming eventually came to America. In the early 1920s, George O. Squier was granted patents for a system for the transmission and distribution of signals over electrical lines, which was the technical basis for what later became Muzak, a technology streaming continuous music to commercial customers without the use of radio. The telephone music service, a live jukebox service, began in 1929 and continued until 1997. The clientele eventually included 120 billion Argentine pesos and restaurants in the Pittsburgh area. A tavern customer would deposit money in the jukebox, use a telephone on top of the jukebox, and ask the operator to play a song. The operator would find the record in the studio library of more than 100,000 records, put it on a turntable, and the music would be piped over the telephone line to play in the tavern. The music media began as 78s, 33s, and 45s, played on the 6 turntables they monitored. CDs and tapes were incorporated in later years. The business had a succession of owners, notably Bill Pearce, his daughter Helen Rutzel, and finally, Duddy White. The revenue stream of each quarter was split 60% to the music service and 40% to the tavern owner. This business model eventually became unsustainable due to city permits and the cost of setting up these telephone lines. History. Early development. Attempts to display media on computers date back to the earliest days of computing in the mid-20th century. However, little progress was made for several decades, primarily due to the high cost and limited capabilities of computer hardware. From the late 1980s through the 1990s, consumer-grade personal computers became powerful enough to display various media. The primary technical issues related to streaming were having enough CPU and bus bandwidth to support the required data rates, achieving real-time computing performance required to prevent buffer underrun and enable smooth streaming of the content. However, computer networks were still limited in the mid-1990s, and audio and video media were usually delivered over non-streaming channels, such as playback from a local hard disk drive or CD-ROMs on the end-user's computer. In 1990 the first commercial Ethernet switch was introduced by Calpana, which enabled the more powerful computer networks that led to the first streaming video solutions used by schools and corporations. Practical streaming media was only made possible with advances in data compression, due to the impractically high bandwidth requirements of uncompressed media. Raw digital audio encoded with pulse code modulation requires a bandwidth of 1.4 Mbit/s for uncompressed CD audio, while raw digital video requires a bandwidth of 168 Mbit/s for SD video and over 1000 Mbit/s for FHD video. Late 1990s to early 2000s. During the late 1990s and early 2000s, users had increased access to computer networks, especially the Internet. During the early 2000s, users had access to increased network bandwidth, especially in the last mile. These technological improvements facilitated the streaming of audio and video content to computer users in their homes and workplaces. There was also an increasing use of standard protocols and formats, such as TCP/IP, HTTP, HTML as the Internet became increasingly commercialized, which led to an infusion of investment into the sector. The band Severe Tire Damage was the first group to perform live on the Internet. On June 24, 1993, the band was playing a gig at Xerox PARC while elsewhere in the building. Scientists were discussing new technology for broadcasting on the Internet using multicasting. As proof of PARC's technology, the band's performance was broadcast and could be seen live in Australia and elsewhere. In a March 2017 interview, band member Russ Haynes stated that the band had used approximately half of the total bandwidth of the Internet to stream the performance, which was a 152 x 76 pixel video, updated 8 to 12 times per second, with audio quality that was, at best, a bad telephone connection. Real Networks pioneered the broadcast of a baseball game between the New York Yankees and the Seattle Mariners over the Internet in 1995. The first symphonic concert on the Internet, a collaboration between the Seattle Symphony and guest musicians Matt Cameron and Barrett Martin, took place at the Paramount Theater in Seattle, Washington, on November 10, 1995. In 1996, Mark Scarpa produced the first large-scale, online, live broadcast, the Adam Yauch-led Tibetan Freedom Concert, an event that would define the format of social change broadcasts. Scarpa continued to pioneer in the streaming media world with projects such as Woodstock 99, Town Hall with President Clinton, and more recently covered CA's campaign Tell a Friend Get Covered, which was live-streamed on YouTube. Business developments. Seeing Technology was founded in 1989, and developed a JPEG streaming product called StreamWorks. Another streaming product appeared in late 1992 and was named StarWorks. StarWorks enabled on-demand MPEG-1 full-motion videos to be randomly accessed on corporate Ethernet networks. StarWorks was from Starlight Networks, who also pioneered live video streaming on Ethernet and via Internet Protocol over satellites with Hughes network systems. Other early companies that created streaming media technology include Progressive Networks and Proto-COMM prior to widespread World Wide Web usage. After the Netscape IPO in 1995, usage of the Internet expanded, and many companies went public, including Progressive Networks. As the web became even more popular in the late 90s, streaming video on the Internet blossomed from startups such as Vivo Software, VideoNet, Precept, and Seeing. Microsoft developed a media player known as ActiveMovie in 1995 that supported streaming media and included a proprietary streaming format, which was the precursor to the streaming feature later in Windows Media Player 6.4 in 1999. In June 1999, Apple also introduced a streaming media format in its QuickTime 4 application. It was later also widely adopted on websites along with Real Player and Windows Media streaming formats. The competing formats on websites required each user to download the respective applications for streaming and resulted in many users having to have all three applications on their computer for general compatibility. In 2000, IndustryView.com launched its world's largest streaming video archive website to help businesses promote themselves. Webcasting became an emerging tool for business marketing and advertising that combined the immersive nature of television with the interactivity of the web. The ability to collect data and feedback from potential customers caused this technology to gain momentum quickly. Around 2002, the interest in a single, unified, streaming format and the widespread adoption of Adobe Flash prompted the development of a video streaming format through Flash, which was the format used in Flash-based players on video hosting sites. The first popular video streaming site, YouTube, was founded by Steve Chen, Chad Hurley, and Jawed Karim in 2005. It initially used a Flash-based player, which played MPEG-4 AVC video and AAC audio, but now defaults to HTML5 video. Increasing consumer demand for live streaming prompted YouTube to implement a new live streaming service to users. The company currently also offers a link returning the available connection speed of the user. The Recording Industry Association of America revealed through its 2015 earnings report that streaming services were responsible for 34.3% of the year's total music industry's revenue, growing 29% from the previous year and becoming the largest source of income, pulling in around $2.4 billion. U.S. streaming revenue grew 57% to $1.6 billion in the first half of 2016 and accounted for almost half of industry sales. Streaming wars. The term streaming wars was coined to discuss the new era of competition between video streaming services such as Netflix, Amazon Prime Video, Hulu, HBO Max, Disney+, Paramount+, Apple TV+, and Peacock. Competition among online platforms has forced them to find ways to differentiate themselves. One key way they have done this is by offering exclusive content, often self-produced and created specifically for a market. This approach to streaming competition can have disadvantages for consumers and for the industry as a whole. Once content is made available online, the corresponding piracy searches decrease. Competition or legal availability across multiple platforms effectively deters online piracy, and more exclusivity does not necessarily translate into higher average investment in content, as investment decisions are also dependent on the level and type of competition in online markets. This competition was increased during the first 2 years of the COVID-19 pandemic as more people stayed home and watched TV. In August 2022, a CNN headline declared the streaming wars are over as pandemic-era restrictions had largely ended and audience growth had stalled. This leads services to focus on profit over market share by cutting production budgets, cracking down on password sharing, and introducing ad-supported tiers. Use by the general public. Advances in computer networking, combined with powerful home computers and operating systems, made streaming media practical and affordable for the public. Standalone internet radio devices emerged to offer listeners a non-technical option for listening to audio streams. These audio streaming services became increasingly popular. Streaming music reached 118.1 billion streams in 2013. In general, multimedia content is data-intensive, so media storage and transmission costs are still significant. Media is generally compressed for transport and storage. Increasing consumer demand for streaming of high-definition content has led the industry to develop technologies such as wireless HD and G.hn, which are optimized for streaming HD content. Many developers have introduced HD streaming apps that work on smaller devices such as tablets and smartphones for everyday purposes. A media stream can be streamed either live or on demand. Live streams are generally provided by a means called true streaming. True streaming sends the information straight to the computer or device without saving to a local file. On-demand streaming is provided by a means called progressive download. Progressive download saves the received information to a local file and then is played from that location. On-demand streams are often saved to files for extended amounts of time, while the live streams are only available at one time only. Streaming media is increasingly being coupled with use of social media. For example, sites such as YouTube encourage social interaction in webcasts through features such as live chat, online surveys, user posting of comments online and more. Furthermore, streaming media is increasingly being used for social business and e-learning. The Horowitz Research State of Pay TV, OTT, and SVOD 2017 report said that 70% of those viewing content did so through a streaming service and that 40% of TV viewing was done this way, twice the number from 5 years earlier. Millennials, the report said, streamed 60% of content. Transition from DVD. One of the movie streaming industry's largest impacts was on the DVD industry, which effectively met its demise with the mass popularization of online content. The rise of media streaming caused the downfall of many DVD rental companies such as Blockbuster. In July 2015, the New York Times published an article about Netflix's DVD services. It stated that Netflix was continuing their DVD services with 5.3 million subscribers, which was a significant drop from the previous year. On the other hand, their streaming services had 65 million members. Napster. Music streaming is one of the most popular ways in which consumers interact with streaming media. In the age of digitization, the private consumption of music transformed into a public good largely due to one player in the market, Napster. Napster, a peer-to-peer file sharing network where users could upload and download MP3 files freely, broke all music industry conventions when it launched in early 1999 in Hull, Massachusetts. The platform was developed by Sean and John Fanning as well as Sean Parker. In an interview from 2009, Sean Fanning explained that Napster was something that came to me as a result of seeing a sort of an unmet need and the passion people had for being able to find all this music, particularly a lot of the obscure stuff which wouldn't be something you go to a record store and purchase, so it felt like a problem worth solving. Not only did this development disrupt the music industry by making songs that previously required payment to acquire freely accessible to any Napster user, but it also demonstrated the power of P2P networks in turning any digital file into a public, shareable good. For the brief period of time that Napster existed, MP3 files fundamentally changed as a type of good. Songs were no longer financially excludable barring access to a computer with internet access, and they were not rival, meaning if one person downloaded a song it did not diminish another user from doing the same. Napster, like most other providers of public goods, faced the freerider problem. Every user benefits when an individual uploads an MP3 file, but there is no requirement or mechanism that forces all users to share their music. Thus, Napster users were incentivized to let others upload music without sharing any of their own files. This structure revolutionized the consumer's perception of ownership over digital goods. It made music freely replicable. Napster quickly garnered millions of users, growing faster than any other business in history. At the peak of its existence, Napster boasted about 80 million users globally. The site gained so much traffic that many college campuses had to block access to Napster because it created network congestion from so many students sharing music files. The advent of Napster sparked the creation of numerous other P2P sites including LimeWire, BitTorrent, and the Pirate Bay. The reign of P2P networks was short-lived. The first to fall was Napster in 2001. Numerous lawsuits were filed against Napster by various record labels, all of which were subsidiaries of Universal Music Group, Sony Music Entertainment, Warner Music Group, or EMI. In addition to this, the Recording Industry Association of America also filed a lawsuit against Napster on the grounds of unauthorized distribution of copyrighted material, which ultimately led Napster to shut down in 2001. In an interview with the New York Times, Gary Stifelman, who represents Eminem, Aerosmith, and TLC, explained, "I'm not an opponent of artists' music being included in these services, I'm just an opponent of their revenue not being shared." The fight for intellectual property rights, IA&M Records, Inc. v. Napster, Inc. None. Music streaming platforms. Although music streaming is no longer a freely replicable public good, streaming platforms such as Spotify, Deezer, Apple Music, SoundCloud, and Amazon Music have shifted music streaming to a club-type good. While some platforms, most notably Spotify, give customers access to a freemium service that enables the use of limited features for exposure to advertisements, most companies operate under a premium subscription model. Under such circumstances, music streaming is financially excludable, requiring that customers pay a monthly fee for access to a music library, but non-rival, since one customer's use does not impair another's. As of 2019, Spotify has over 207 million users in 78 countries. As of 2018, Apple Music has about 60 million. And SoundCloud has 175 million. All platforms provide varying degrees of accessibility. Apple Music and Prime Music only offer their services for paid subscribers, whereas Spotify and SoundCloud offer freemium and premium services. Napster, owned by Rhapsody since 2011, has resurfaced as a music streaming platform offering subscription-based services to over 4.5 million users as of January 2017. The music industry's response to music streaming was initially negative. Along with music piracy, streaming services disrupted the market and contributed to the fall in U.S. revenue from $14.6 billion in 1999 to $6.3 billion in 2009. CDs and single-track downloads were not selling because content was freely available on the Internet. By 2018, however, music streaming revenue exceeded that of traditional revenue streams. Streaming revenue is now one of the largest driving forces behind the growth in the music industry. In an interview, Jonathan Dworkin, a senior vice president of strategy and business development at Universal, said, "We cannot be afraid of perpetual change, because that dynamism is driving growth." COVID-19 pandemic. By August 2020, the COVID-19 pandemic had streaming services busier than ever. In the UK alone, 12 million people joined a new streaming service that they had not previously had. An impact analysis of 2020 data by the International Confederation of Societies of Authors and Composers indicated that remuneration from digital streaming of music increased with a strong rise in digital royalty collection, but it would not compensate the overall loss of income of authors from concerts, public performance, and broadcast. The International Federation of the Phonographic Industry recompiled the music industry initiatives around the world related to the COVID-19. In its State of the Industry report, it recorded that the global recorded music market grew by 7.4% in 2022, the sixth consecutive year of growth. This growth was driven by streaming, mostly from paid subscription streaming revenues which increased by 18.5%. fueled by 443 million users of subscription accounts by the end of 2020. The COVID-19 pandemic has also driven an increase in misinformation and disinformation, particularly on streaming platforms like YouTube and podcasts. Technologies. Bandwidth. A broadband speed of 2 Mbps or more is recommended for streaming standard definition video without experiencing buffering or skips, especially live video, for example to a Roku, Apple TV, Google TV, or a Sony TV Blu-ray disc player. 5 Mbps is recommended for high-definition content and 9 Mbps for ultra-high-definition content. Streaming media storage size is calculated from the streaming bandwidth and length of the media using the following formula: storage size in megabytes is equal to length times bitrate /. For example, 1 hour of digital video encoded at 300 kbits/s will be requires around 128 MB of storage. If the file is stored on a server for on-demand streaming and this stream is viewed by 1,000 people at the same time using a unicast protocol, the requirement is 300 kbits/s times 1000 equals 300,000 kbits/s equals 300 Mbits/s of bandwidth. This is equivalent to around 135 GB per hour. Using a multicast protocol, the server sends out only a single stream that is common to all users. Therefore, such a stream would only use 300 kbits/s of serving bandwidth. See below for more information on these protocols. The calculation for live streaming is similar. Assuming that the speed at the encoder is 500 kbits/s and if the show lasts for 3 hours with 3,000 viewers, then the calculation is number of MBs transferred equals encoder speed times number of seconds times number of viewers / The results of this calculation are as follows: number of MBs transferred equals 500 x 1024 times 3 times 3600 times 3000 / equals 1,977,539 MB. In 2018, video was more than 60% of data traffic worldwide and accounted for 80% of growth in data usage. Protocols. The audio stream is compressed to make the file size smaller using an audio coding format such as MP3, Vorbis, AAC or Opus. The video stream is compressed using a video coding format to make the file size smaller. Video coding formats include H.264, HEVC, VP8 or VP9. Encoded audio and video streams are assembled in a container bitstream such as MP4, FLV, WEBM, ASF, or ISMA. The bitstream is delivered from a streaming server to a streaming client using a transport protocol, such as Adobe's RTMP or RTP. In the 2010s, technologies such as Apple's HLS, Microsoft's Smooth Streaming, Adobe's HDS and non-proprietary formats such as MPEG- have emerged to enable adaptive bitrate streaming over HTTP as an alternative to using proprietary transport protocols. Often, a streaming transport protocol is used to send video from an event venue to a cloud transcoding service and CDN, which then uses HTTP-based transport protocols to distribute the video to individual homes and users. The streaming client may interact with the streaming server using a control protocol, such as MMS or RTSP. The quality of the interaction between servers and users is based on the workload of the streaming service. As more users attempt to access a service, the more quality is affected unless there is enough bandwidth or the host is using enough proxy networks. Deploying clusters of streaming servers is one such method where there are regional servers spread across the network, managed by a singular, central server containing copies of all the media files as well as the IP addresses of the regional servers. This central server then uses load balancing and scheduling algorithms to redirect users to nearby regional servers capable of accommodating them. This approach also allows the central server to provide streaming data to both users as well as regional servers using FFmpeg libraries if required, thus demanding the central server to have powerful data processing and immense storage capabilities. In return, workloads on the streaming backbone network are balanced and alleviated, allowing for optimal streaming quality. Designing a network protocol to support streaming media raises many problems. Datagram protocols, such as the user datagram protocol, send the media stream as a series of small packets. This is simple and efficient, however, there is no mechanism within the protocol to guarantee delivery. It is up to the receiving application to detect loss or corruption and recover data using error correction techniques. If data is lost, the stream may suffer a dropout. The Real-Time Streaming Protocol, Real-Time Transport Protocol and the Real-Time Transport Control Protocol were specifically designed to stream media over networks. RTSP runs over a variety of transport protocols, while the latter two are built on top of UDP. Another approach that seems to incorporate both the advantages of using a standard web protocol and the ability to be used for streaming even live content is adaptive bitrate streaming. HTTP adaptive bitrate streaming is based on HTTP progressive download, but contrary to the previous approach, here the files are very small, so that they can be compared to the streaming of packets, much like the case of using RTSP and RTP. Reliable protocols, such as the Transmission Control Protocol, guarantee correct delivery of each bit in the media stream. However, they accomplish this with a system of timeouts and retries, which makes them more complex to implement. It also means that when there is data loss on the network, the media stream stalls while the protocol handlers detect the loss and retransmit the missing data. Clients can minimize this effect by buffering data for display. While delay due to buffering is acceptable in video-on-demand scenarios, users of interactive applications such as video conferencing will experience a loss of fidelity if the delay caused by buffering exceeds 200 milliseconds. Unicast protocols send a separate copy of the media stream from the server to each recipient. Unicast is the norm for most Internet connections, but does not scale well when many users want to view the same television program concurrently. Multicast protocols were developed to reduce the server/network loads resulting from duplicate data streams that occur when many recipients receive unicast content streams independently. These protocols send a single stream from the source to a group of recipients. Depending on the network infrastructure and type, multicast transmission may or may not be feasible. One potential disadvantage of multicasting is the loss of video-on-demand functionality. Continuous streaming of radio or television material usually precludes the recipient's ability to control playback. However, this problem can be mitigated by elements such as caching servers, digital set-top boxes, and buffered media players. IP multicast provides a means to send a single media stream to a group of recipients on a computer network. A multicast protocol, usually Internet Group Management Protocol, is used to manage delivery of multicast streams to the groups of recipients on a LAN. One of the challenges in deploying IP multicast is that routers and firewalls between LANs must allow the passage of packets destined to multicast groups. If the organization that is serving the content has control over the network between server and recipients, then routing protocols such as protocol-independent multicast can be used to deliver stream content to multiple local area network segments. Peer-to-peer protocols arrange for pre-recorded streams to be sent between computers. This prevents the server and its network connections from becoming a bottleneck. However, it raises technical, performance, security, quality, and business issues. Recording. Media that is live-streamed can be recorded through certain media players such as VLC player, or through the use of a screen recorder. Live streaming platforms such as Twitch may also incorporate a video-on-demand system that allows automatic recording of live broadcasts so that they can be watched later. The popular site, YouTube, also has recordings of live broadcasts, including television shows aired on major networks. These streams have the potential to be recorded by anyone who has access to them, whether legally or otherwise. Applications and marketing. Useful and typical applications of streaming are, for example, long video lectures performed online. An advantage of this presentation is that these lectures can be very long, although they can always be interrupted or repeated at arbitrary places. There are also new marketing concepts. For example, the Berlin Philharmonic Orchestra sells internet live streams of whole concerts, instead of several CDs or similar fixed media, by their digital concert hall using YouTube for trailers. These online concerts are also spread over a lot of different places, cinemas at various places on the globe. A similar concept is used by the Metropolitan Opera in New York. There also is a live stream from the International Space Station. In video entertainment, video streaming platforms like Netflix, Hulu, and Disney are mainstream elements of the media industry. Marketers have found many opportunities offered by streaming media and the platforms that offer them, especially in light of the significant increase in the use of streaming media during COVID lockdowns from 2020 onwards. While revenue and placement traditional advertising continues to decrease, digital marketing increased in 15% in 2021, with digital media and search representing 65% of the expenditures. A case study commissioned by the WIPO indicates that streaming services attract advertising budgets with the opportunities provided with interactivity and the use of data from users, resulting in personalization on a mass scale with content marketing. Targeted marketing is expanding with the use of artificial intelligence, in particular programmatic advertisement, a tool that helps advertisers decide their campaign parameters, and whether they are interested in buying advertising space online or not. One example of advertising space acquisition is real-time bidding. Challenges. Copyright issues. The availability of large bandwidth internet enabled the audio-visual streaming services to attract large number of users around the world. For OTT platforms, original content represents a critical variable in order to capture more subscribers. This generated a number of effects related to the copyright over the audio-visual content and its international exploitation through streaming, such as contractual practices, international exploitation of rights, widespread use of standards and metadata in digital files. The WIPO has indicated the several basic copyright issues arising for those pursuing to work in the film and music industry in the era of streaming. Streaming copyrighted content can involve making infringing copies of the works in question. The recording and distribution of streamed content is also an issue for many companies that rely on revenue based on views or attendance. Greenhouse gas emissions. The net greenhouse gas emissions from streaming music were estimated at between 0.2 and 0.35 million metric tons CO2 eq per year in the United States, by a 2019 study. This was an increase from emissions in the pre-digital music period, which were estimated at 0.14 million metric tons in 1977, 0.136 million in 1988, and 0.157 million in 2000. However, this is far less than other everyday activities such as eating. For example, greenhouse gas emissions in the United States from beef cattle were 129 million metric tons in 2019. A 2021 study claimed that 1 hour of streaming or video conferencing emits 151,000 grams of carbon dioxide, requires 212 liters of water, and demands a land area adding up to about the size of an iPad mini. The study suggests that turning the camera off during video calls can reduce the greenhouse gas and water use footprints by 96%, and that an 86% reduction is possible by using standard definition rather than high definition when streaming content with apps such as Netflix or Hulu. However, another study estimated a relatively low amount of 36 grams per hour, and concluded that watching a Netflix video for half an hour emitted only the same as driving a gasoline-fueled car for about 100 meters, so not a significant amount. One way to decrease greenhouse gas emissions associated with streaming music is making data centers carbon neutral, by converting to electricity produced from renewable sources. On an individual level, purchase of a physical CD may be more environmentally friendly if it is to be played more than 27 times. Another option for reducing energy use can be downloading the music for offline listening, to reduce the need for streaming over distance. The Spotify service has a built-in local cache to reduce the necessity of repeating song streams.